Hi there, this is Mr. Alexander, and today I want to talk to you about some calculator strategies for the chi-square test of independence. Now, to do that, I've taken a question out of the online textbook here. It says, Rachel claims that girls take more black and white color photographs than boys, but Jack, who's a photographer, is skeptical. If Jack collects the following data, would it be correct to say that he should reject Rachel's claim that gender affects tendency to take photographs? And we've got female, male, black and white, color. So what I'm going to do is I'm going to transfer that information. I've got male and female. We've got black and white and color as well. And we've got some numbers we can transfer over as well. We've got 72, 48, 489, and 530. So, we'll start with the null hypothesis. The null hypothesis is always that two variables are independent. So, in this case, we should make the null hypothesis that gender and preference for the color of your photographs is independent. So let's write that. Gender and photograph color are independent, and that's true of every chi-square test. It's just that whatever the two variables you're looking at, they're independent. So the alternative hypothesis is very simple. You just put the word not in there. You'd say they're just not independent, or you say they're dependent, or there's a relationship between the two. So I'm just going to say gender and photograph color are dependent. Now, I didn't include any totals yet, so I'm just going to grab those totals. We got the 561, the 578, the grand total of 1,139, 120, and 1019. So now, the next step here after writing our hypotheses are to look at the expected counts. So the way you calculate expected counts, and when I say expected, what I'm saying is what I would expect to see, the totals I would expect to see, or the individual cells I'd expect to see, if indeed the null hypothesis is true. If the two variables are independent, then what would I expect to see for black, white, male, female, and color, male and female. Now, you always want to start by writing in the totals first. 578, 120, 1019, 1139. Now, the way you're going to make that calculation is the row total times the column total divided by the grand total. Row total times column total divided by the grand total now. So here, 120 times 561 divided by the grand total of 1139. If indeed the null hypothesis is true, and these two variables are independent, we would expect there to be 59.1 observations in the cell. In fact, there were 72. Does that mean that they're not independent? Not necessarily. We're going to see if it's different enough. That's what the whole point of this test is. It has to be different enough for us to reject the null hypothesis. So I'm going to do these other calculations here. So that would be 561 times 1019 divided by 1139. And that would be 501.9. For the females then, 120 times 578 divided by 1139. That's 60.9, making sure that these total to 120, which they do. And then finally this last cell, 578 times 1019 divided by 1139 is 517.1. Making sure that these total to 578, and they appear to indeed total to 578. So we've got these expected margins here, and I always like to take a look at them and make sure that they're all above 5, because that's one of the conditions for the chi-square test of independence, is to make sure that all of these are above 5, which they are, which means we can feel pretty confident with the results of this test. If it's less than 5, we might have some issues. Doesn't mean you can't do the test, just means you have to be aware of it, that there might be an issue. To calculate the chi-square statistic, what we're going to do is take these observed values, subtract off the expected values, square it, and then divide it by the expected value. And this just means the sum up, so we're going to add them all together. So I'm going to take 72 minus 59.1 divided by 59.1. Oops. I'm going to square that, plus 501.9, oops, 489 minus 501.9 divided by 501.9. Square that, and I've got 48 minus 60.9 squared divided by 60.9. And then I'm going to do the last observed, which is 530 minus 517.1 squared divided by 517.1. If this seems cumbersome, it is. I'm going to show you how to do it all on the calculator in mere moments. Before I do, I just want to calculate it by hand. So I'm going to type all these in. I've got 72 minus 59.1 squared divided by 59.1 plus 489 minus 501.9 squared divided by 501.9 plus 48 minus 60.9 squared divided by 60.9, and then finally plus 530 minus 517.1 squared divided by 517.1. And that's going to give me a chi-square statistic of 6.20. Question is that big enough to reject the null hypothesis? What you need to know is the chi-square critical value, and that comes from the critical table. In this critical table, you need to know two things. You need to know the degrees of freedom and the significance level. We're going to, as always, we're going to assume the significance level of 0.05 unless we are told otherwise. So, we need to first identify the degrees of freedom. And the degrees of freedom are easy to calculate. It's the number of rows minus 1 times the number of columns minus 1. Or in this case, it was 2 minus 1 times 2 minus 1. Why 2 and not 3? You don't include the totals, only the actual observations. So 2 by 2. Don't include the totals, row or the total column. So 2 minus 1 times 2 minus 1 is just 1. And a chi-square test is always a one-tailed test. There's no such thing as a two-tailed chi-square test. And the chi-square distribution looks something like this, where this is 0 and this is going off into infinity. So if I want to know this critical value right here, again, it's always going to be one tail. I'm going to 1 degree of freedom and we're just going to assume 0.05 unless I'm told otherwise. But in this case, 0.05 is fine, so 3.84. And so that's my chi-square critical is 3.84, which would tell me that since my chi-square statistic at 6.2 is inside the critical region, I'm going to reject the null hypothesis, which means that the two variables are dependent or not independent. So that's how you run the whole test, but the reason you're probably watching this is to see how to do it on the calculator. Very simple on the calculator. You really only need to do one thing. You need to go to the matrix screen here, which is second x to the negative first power. Pulls up this matrix screen. You want to edit matrix A, and it's the only matrix you need to edit. You're going to do a 2 by 2 because you're not going to include the totals. And we're just going to put in the observed values, the 72, the 489, the 48, and the 530. And that's really all the work you need to do, because from here you can go to Stat, Tests, and if you scroll down to chi-square test, if you have an 84, there's a goodness of fit test as well. My next video will be about that. Just stick to the chi-square test for now. It says expected is in matrix B. We didn't put anything in matrix B, but that's okay. You'll see why in a second. When I calculate this, chi-square is 6.2, which is exactly what we got. And that's a p-value of less than 0.05, which is what we got since we rejected the null hypothesis, with 1 degree of freedom. So this is a great way to double check your work. Now you're saying we didn't put anything in those expected values. Well, if I go back to the matrix screen again, you can see there's something in matrix B now. And you can scroll down there, you can edit matrix B, and you can actually see those expected values, and you can compare them to what we calculated, and you'll see that they're just about exactly the same. So this is an excellent way to double check those expected values as well. And that's the whole chi-square test. So now you can do it by hand, you can do it on the calculator, whichever you prefer. Both methods are great. The only time I would have reservations about using the calculator is if they're very specific rounding rules, like if they said round this to 1 or 2 decimal places and then use those numbers down here, that might lead to a slightly different answer for the chi-square statistic. So as always, I say this in every video, use the calculator to double check your work that you've done by hand. Don't make it your primary source of information. Alright, thanks for watching chi-square test of independence. I'll see you at the next video, which is the chi-square goodness of fit test.